And so now we can compare the prediction with the solution. Okay, we know the solution of the decay problem. And this is now an example which is very, very similar to the concentration of the wine content for the wine thief example. Okay, so you start with 100%, and then you have an analytical solution, which is the black line. And I show you solutions for the explicit and the implicit scheme using a time step of 1 hour. Okay, the time step is written here, it's 1 hour, and the kappa constant is given here too. Okay, and this is what happens now. Now you'll be surprised that explicit scheme always under predicts the concentration, and the implicit scheme always over predicts the concentration, always a little bit ahead. Okay, so well, how can you improve your prediction? Well, in this case, you can just use smaller time steps. Because the smaller you choose the time step, the closer should be your prediction result to the real solution. Okay, so this is one way, but there's another solution. If you don't want to, if it's if the simulation would take too long with small time steps, what you can do is you can also think of solution which is shown here, hybrid scheme, where you actually start with an equation where you have an implicit term and an explicit term, and you have a weighting between these two. You know, you have a weighting factor that you can change the number. You can either, it tells you what fraction you use explicit and which fraction you use implicit. And this is how you can tune it actually, that it gives you a perfect prediction. So so-called hybrid scheme. Okay, so there's quite a bit of learning in this. Okay, so quite a bit of learning for you.